everyone, and welcome to the mass flow rate calculation part 2. Today we will talk about how to calculate the mass flow rate of an orifice where the pressure level after the orifice is not ambient. If you missed the previous video about the air reservoir calculation when the outflow pressure is the ambient pressure, so basically when we're emptying the reservoir, please go and watch this video again because it's very important for the calculations of today. So, based on the previous derivations, we know that our mass flow rate depends on the surface, on the orifice where it passed through, on the diameter of the pressure level, density, and also outflow function. In this calculation, we also introduce the alpha D. Alpha D is the loss factor. So it can be 20%, 10%, 15%, or 30%. Nothing is ideal in this world. So this is going to be our loss or safety factor that we need always to calculate. So doing again some magic, and we now have an equation for the mass flow rate through the orifice. And it depends, again, outflow function, our geometry parameters, gas constants, temperature, density, pressure. And it depends a lot on our condition. It depends a lot on our critical pressure ratio. So our outflow condition or our flow condition, they depend in which state our flow is. It depends on our critical relation between the P2 and P1. So from the last video, you remember that we have supersonic and subsonic conditions. So we have a condition where the pressure ratio, with a certain pressure ratio, where the flow becomes the constant and it doesn't change at all. Or we have where the condition in the subsonic, where the flow depends on our B value on our pressure ratio. Following that, we have various conditions and we have various calculations of the mass flow rate. So it means before you start calculating your mass flow rate, please calculate and check in which condition you are standing. If your pressure is in subsonic or supersonic, so we just divide P1 to P2, P2 to P1, and compare to our ideal value. So if you don't remember, our ideal value is 0.528. This is the critical pressure.